Hello everyone, welcome back to Math Lesson Videos. For this lesson video, we will discuss about angle of elevation and angle of depression. Our lesson objectives for today are to utilize the trigonometric and inverse trigonometric functions in a calculator, define and differentiate angle of elevation and depression, calculate distance and angle measures when working with right triangles, and solve word problems involving angles of elevation and depression. The references for today's video are eMath 9 from Rex Bookstore, Pre-Calculus by Ateneo de Manila University Press, images came from Google, and the PowerPoint template from allppt.com. Okay, let's start with trigonometric functions in calculator together with inverse trigonometric function. Starting with the angle measurement using the degree system. 1 degree is equal to 60 minutes, or 1 minute is equal to 1 over 60 degrees. 1 minute is equal to 60 seconds. Therefore, 1 second is equal to 1 over 60 minutes. So, 1 second is 1 over 60 minutes, or 1 over 3,600 degrees. Okay, let us convert 52 degrees and 10 minutes to decimal. So for this, we can use our calculator. So we have 52 degrees and 10 seconds. So we can convert, or we can rewrite 52 degrees and 10 minutes in decimal form by adding 52 and 10 over 60. Why 10 over 60? Because 1 minute is equivalent to 1 over 60 degrees. So 10 minutes is the same as 10 over 60 degrees. So 52 degrees and 10 minutes is the same as 52. So in two decimal places, we are going to round it as 0.17. How are we going to write 5 degrees, 27 minutes, and 30 seconds in decimal form? 5 degrees will still be 5 plus 27 minutes will be written as 27 over 60 because 1 minute is 1 over 60 degrees plus 30 over 3,600 because 1 second is equal to 3,600. We can round it off into two decimal places as 5.46. Now let's have the last example, 13 degrees, 24 minutes, and 75 seconds. So that will be 13 plus 24 over 60 plus 75 over 3,600. In decimal, that is 13.42 when we round it off to two decimal places. We forgot to put the degree. Now, let us use the calculator in getting the trigonometric ratios of angles that are not special. So, those are the angles that are not 0, 30, 45, 60, and 90. Okay, but first, you have to make sure that your calculator is set in degree mode. So, how are we going to know that it's set in degree mode? If you will see the D or deg on top of your calculator. So, we will be getting the 6 trigonometric ratios of the following angles: 15 degrees, 37 degrees, 50 degrees, 75 degrees, and 88 degrees using our calculator. First, let's start with the sine function. We will get the value of sine 15. So, how are we going to use our calculator? You will see here that we have 3 trigonometric ratios, the sine, cosine, and tangent. Okay, so to get the value of sine 15 degrees, now that we are sure that our calculator is set in degree, just press or click sine, then type the angle measure that you want to get. So sine 15 is equal to, okay, when it is written in radical form, that is square root of 6 minus square root of 2 all over 4. But in decimal form, we are going to write our values into, let's say, 4 decimal places. So here we have 0.258819041. We will only limit to 4 decimal places, so we will get 0.2588. Since on the right of 8, we have 1, it will be written as 0.2588. Or let us get the value of cosine 15 degrees. So cosine is on the right of sine. Just press cos or click cos, then 15 degrees. So it's 6 square root of 6 plus square root of all over 4. So it's 0.965925823. If we are going to write it in 4 decimal places, we will only get 9659, and on the right of 9 is 2. So it will be as is. Now let's get the tangent of 15 degrees. For the 3 ratios, it is easy to get because sine, cosine, and tangent are already in the calculator. You just need to press. Okay, so we will now get tangent of 15 degrees. Just click or press tan, then type 15. So we have 2 minus square root of 3, or in decimal, it is 0.267949194. So in 4 decimal places, we will get 0.2679, and on the right of 9 is 4, so we will only write 0.2679. So tangent 15 is 0.2679. Now let us get the reciprocal trigonometric ratios. The reciprocal of tangent is cotangent. The reciprocal of cosine is secant. And the reciprocal of sine is cosecant. Okay, let's start with cotangent 15 degrees. We know that cotangent is the reciprocal of tangent. Therefore, the reciprocal of tangent is 1 over tangent. So we will just type 1 divided by tangent 15 degrees. There we will get the value of cotangent 15 degrees, which is plus square root of 3, and in decimal that will be 3.7320508808, and in 4 decimal places, we are going to change 0 to 1 because the number on the right is 5. So it will be rounded up. So for cotangent 15, we have 3.7321. Okay, now let us get secant of 15 degrees. Secant is the reciprocal of cosine. So secant will be entered as 1 over cosine. We have square root of 6 minus square root of 2, or 1.0352, and on the right of 2 is 7, so we will write our answer as 1.0353. Okay, then the cosecant of 15 degrees, cosecant is, and the cosecant of 15 degrees, so cosecant is the reciprocal of sine, so cosecant will be entered as 1 over sine 15 degrees. Okay, and we will get 6 plus square root of 6 plus square root of 2, or 3.8637. Okay, so using our calculator, we can also get the 6 trigonometric ratios of 37 degrees, 50 degrees, 75 degrees, and 88 degrees. So we're going to solve for 37 degrees. The 6 trigonometric ratios of 37 degrees using our calculator. Then you can do the rest using your calculator. So sine 37 degrees will simply be entered as sine 37. Again, make sure that your calculator is set in degree mode. Okay, so that will be 0.6018. So sine 37 degrees is 0.6018. Then cosine 37 degrees, when we enter in our calculator, we will just type cosine 37. Okay, so when we input it in the calculator, we will just type cosine. For cosine, we have cosine 37. So that will be 0.7986. Tangent 37 is 0.7356y6 because on the right of 5 is another 5, so we will round it up. And for cotangent, so we have 1 over tangent 37. Okay, so 0.3270, and secant is 1 over cosine. So that will be 1.2521, and cosecant is 1 over sine. So we have 1.661. Now we have learned how to use our calculator in getting the trigonometric ratios of non-special angles. Okay, now, if we need to find the measure of the angle, how are we going to solve for it using our calculator? Suppose we have AX is equal to Y over Z. We want to find the value of X. So what do? We need to isolate X, multiply both sides by the reciprocal of A to get the value of X. And the reciprocal of A is 1 over A. Okay, so when we multiply or when we distribute 1 over A to our equation, so we will divide out A, leaving us with X. Then multiply to the other side, we have 1 over A times Y over Z. Okay, when we discuss exponentiation, we know that 1 over A is equivalent to A raised to negative 1. We can multiply the equation by A raised to negative 1. Now, what if we are trying to find out theta or the measure of the angle using our calculators? We will use this process. Okay? So, suppose we are looking for the value of theta. Say that we have sine. Okay? So, we know that sine theta is equal to the opposite side divided by the hypotenuse. Okay, we only want to find theta. So how are we going to put sine on the other side? So same with the previous example, we will multiply our equation by sine raised to negative 1. Okay, so sine times sine raised to negative 1 will become sine raised to 0, or any number raised to 0 is 1. So that will only leave us with theta. And this will be sine raised to negative 1 times the quotient of the opposite and the hypotenuse when divided. Okay, so we will use this inverse trigonometric function, the inverse of sine, which is sine raised to negative 1, or what we call as the arc sine. Okay, so sine raised to negative 1 is also known as the arc sine. Let us use this inverse trigonometric function in finding the measure of our angles. Let us have our first example. Okay, so we have here triangle BHR. How are we going to find the measure of angle B and angle R if all of the sides are given? So we will be looking for angle B first. So that will be our theta. And what will be the measure of angle R? Since the two acute angles of any right triangle are complementary, and complementary means that the sum of the angles is 90. So R will here will be 90 minus theta. Okay, all sides are given. We can use either sine, cosine, or tangent. So let's just use sine first. Okay, so from the previous slide, we learned that to get the value of theta, so we previously have sine theta, which is opposite over hypotenuse. To get the value of theta, we just multiply both sides by sine raised to -1 or arc sine. So, when we multiply sine and sine raised to -1, that will give us sine raised to 0. And any number raised to 0 will always be 1. So 1 times theta is theta. Theta is equal to sine raised to -1 or arc sine of opposite side over the hypotenuse. So in our given triangle BHR, we need to find angle B, which is represented by theta. So it will be sine raised to -1. The side opposite theta measures 12 units and the hypotenuse is 15 units. We can input this directly in our calculator so we can get straight the value of theta. So how do we work on it with calculator? So let's go to our calculator. To get the arc sine function in our calculator, we have to use the button shift so we can get the second function. The second functions are found on top of the button. So look at the top of sine, you will see there sine raised to -1. That is the second function. And the letter D there is the alphabet. So we will just press alpha for that. But we do not need that. We need sine raised to -1 or what we call as our arc sine. The inverse of sine is arc sine. So we will just click or press shift. So you will see an S icon that appears on top of our calculator. Then select sine. Now, instead of displaying sine, we have sine raised to -1, which means we are getting the inverse trigonometric function or the inverse of sine, which is arc sine. Then, input our opposite side divided by the hypotenuse, which is 12, divided by, we have 53, and we will only write it in 2 decimal places. So, theta is equal to, where are we going to find the measure of the other angle, R? We just subtract 53.13 from 9. Subtract 53.13 from 90. And by the way, inverse trigonometric function and reciprocal trigonometric ratios are not the same. When we get the reciprocal, we just interchange the side opposite, the hypotenuse, and the side adjacent. But for inverse trigonometric function, we're looking for the value or the measure of the angle. So we have here 90 minus arc sine, which is shift sine of 12 over 50, giving us 36.87 because the number on the left or on the right of 6 is 9, and we round it off as 36.87. Okay, so we have completed the measures in triangle BHR. Let's now move to our next triangle, BSD, BDS, whatever you want. So let's find angle B. So let this be our theta, and this will be our 90 minus. So from the previous example, we used sine. This time, let's use cosine. So we are referring to angle B, which is our theta. So we know that cosine theta is equal to side adjacent divided by the hypotenuse. And to get the measure of theta, we multiply both sides by arc cosine or cosine raised to -1. So to find theta in example number 2, we have arc cosine times the side adjacent, which is 15, divided by our hypotenuse, which is 25. So when we type it in our calculator, arc cosine will be shift cosine times 15 divided by 25, giving us 53.30, or the same as our first example. So theta here is 53.13. Similarly, our angle B, which is 90 minus theta, will be 36.887 if all of them are equal. Okay, let's have question number 3. Question number 3, we have triangle MPT, whose sides are 15, 8, and the hypotenuse is 17. So we used cosine, sine. Now let's use tangent. So tangent theta is opposite side over the adjacent side. To get theta, given that we have tangent, so we will arc tangent, opposite side over the adjacent side. So in this example, let's just get M. M will be our theta. So let's find theta first. Arc tangent, opposite side. So the side opposite theta is 8 over the side adjacent theta, which is 15. So again, using our calculator, we can get the measure of the angle or the measure of theta by getting the second option or the second function. So shift tangent, our opposite over adjacent. So 8 over 15. Then we get 28.07. We'll just round it up to 2 decimal places. So is now to get the measure of 90 minus theta. So we have 61.9. Again, the measure is this. Okay, let's have our last example. We have triangle GPM, whose sides are 24 and 32, and the hypotenuse is 40. So let's look for angle. Let us use sine again. So sine theta is opposite over hypotenuse. So to get the value of theta, we have to multiply by arc sine, so opposite over hypotenuse. So in this example, our angle G is our theta. The side opposite theta, our angle G, measures 32 units, and the hypotenuse is 40 units. So theta is equal to arc sine times opposite, which is 30, over the hypotenuse, which is 40. So in our calculator, we just type, or we just click shift, then sine times the ratio 32 and 40, or arc sine, the quotient of 32 and 40. Again, to find the measure of angle M, we just have to subtract 53.13 degrees from 90.